All right, multiplying and dividing radicals. You can easily multiply and divide radicals that have the same index. So for example, in number 9, they have the same index. You just multiply the insides and then simplify, or you can simplify and then you can multiply the insides. It's up to you. But expressions with different indices are more complicated, and we will do some of those too. Let's look at number 9. Would you guys like to simplify root 90 and root 75 first, or would you like to multiply them and then simplify? I'm going to go with that too, because if we did it the other way, we might end up simplifying, multiplying, and then have to simplify again. And this time, we just have to simplify once. So I'm with you on that. All right. So we got to multiply 90 times 75. Anybody got that?
6,750.
Is that it?
Yeah.
Okay. 6,750 cube root. All right, I've got to do a factor tree for 6,750. What would be two numbers that would be good to start with?
90 and 75.
Thank you. I am so glad you saw that. Okay. We just multiplied 90 and 75 to make 6,750. We might as well use those to break it up, right? Very good. So we're going to do 90, 75. I broke up 75, I think, on the other side. I did 25 times 3 and 5 times 5. For the 90, I'm going to do 9 times 10, 3 times 3, and 2 times 5. So don't lose track of any of these on your factor tree. Everything at the bottom is something that has to be included. Got all of those. So I have cube root 2, 1, 2, 3. So you could write 3, 3, 3, or you could write 3 to the 3. And the same with the 5s. You can write 5, 5, 5, or you can write 5 to the 3. All right, the 2, I don't have enough 2's to take it out, so the 2's got to stay underneath. But I've got 3 to the 3 and I've got 5 to 3. Those will cancel out with the cube root, so I can take them out. I've got 3 times 5, which is 15 on the outside. Cube root 2. Okay, I did skip writing a step there. I skipped showing you 3 times 5 on the outside. That's where the 15 comes from. All right, so we're going to do 11 because they have the same index. We're going to start by multiplying the outsides, which is just 2. And then multiply the insides. 3 times 6 is 18. X to the 3. Y to the what? Y to the 6, yep. All right, this is a square root, so we need 2 of things in order for it to come out. I'm going to do the factor tree for 18. So I have 2 square root 3 squared times 2. I have x to the 3, but I need an x to the 2 in order for it to come out. So I'm going to make it x to the 2 times x to the what? X to the 2 times x to the 1. For the y to the 6, I've got y squared, and I can make another y squared. So all those are y squareds. All right, so I'm doing that because square root and squaring will undo each other, and they can come out of the root. So this 2 is already out here. I'm going to bring out the 3. So I've got 3 times 2. Let me circle the things I'm bringing out. I'm going to bring out that x and all 3 of these y's. And then, so I've got x. I've got y. You can write y to the 3rd right away if you know that's what that's going to be. And then underneath the square root, I've got 2x. All right, so 3 times 2 is 6. X, y to the third, square root of 2x. Yeah, I don't love this section because this section is a lot of me doing problems, but the next section you guys will get to do more. All right, we're going to look at number 10 next. Number 10 has different indices, so we can't do it the same way. What we are going to do with number 10 is we're going to change the radical to an exponent. So for example, we learned last lesson that a square root is the same as what exponent? It's a fraction. Square root is the same as what fraction exponent? All right, go ahead. A half, yeah. Square root is a half, cube root is a third, fourth root is 1/4. That was from last lesson, okay? All right, so let's look up here. I'm going to change this to be 4x to the 1/3. That's a weird x to the 1/3. And that's going to be 5 to the 1/4. Now, I didn't change anything. That's just a different way of writing the same thing. That's how you write a radical with an exponent. Sorry about the x. The x turned out really weird there. I think I thought I was writing something else. All right. I want to be able to combine these into the same root, so I need a common denominator. So 3 and 4, what common denominator can I get? 12, yeah. So let's multiply the first one times 4/4. And then the second one times 3/3 to get a common denominator of 12. So I have 4x to the 4/12 times 5 to the 3/12. Now what I'm going to do is I'm going to put this back in a root. What would be the index of the root, looking at those fractions?
4x to the 12 to the 4 on the outside.
So you're right that 4 is going to be the exponent. And Annika, what's going to be the index? 12. Good. Okay. So we're going to make 12th root 4 to the 4, x to the 4. 5 to the 3. Now, we can actually get a number out of some of that. So what we're going to do is go into Desmos and figure that out. That's not something I'm about to do in my head. All right, so we need to do 4 to the 4 times 5 to the 3. I'm getting 32,000. And the good news is there is not an integer that we can take out of the 12th root of 32,000. So we get to just leave that there. So it's going to be finally 12th root 32,000 x to the 4. All right, so in number 12, in order to get rid of the square root in the denominator, you multiply both the numerator and denominator by that square root. I'm allowed to do that because I'm really essentially just multiplying by 1. Root 2x divided by root 2x is 1. Oh, that's really small. You can't even see that. Sorry. I'm multiplying it by root 2x over root 2x. Now, what this is going to do is get rid of the square root in the denominator, and it's actually going to put the square root in the numerator. And some people would say that's not really simple, but mathematicians decided that this was a rule a long time ago, that you can't have a radical in the denominator. So, in the denominator, all right, So in the denominator, we get the square root of 2x, the quantity squared, or the product squared. So it's like 2 squared, x squared, and the square root of that. But the squaring and the square root are going to cancel out. So the easiest thing to realize is that the squaring and the squaring are going to cancel out in the denominator, and you just get 2x. In the numerator, you get 14 root 2x. Okay, so this is going to give us a square root of the same thing. Yes?
This is not really in the subject, but I was supposed to leave at 12.
All right. Does anybody want to see that the step that I skipped over? You're allowed to say yes. Okay. So when I multiply root 2x times root 2x, I just get 2x. On the top, I get 14 root 2x. Now, this 2x and this 2x cannot simplify because one's in a root and one's not. However, the 14 and the 2 can simplify. So 14 divided by 2 will simplify to what? It's 7. Yeah, you can write 7 over 1 if you want, or you can just make it 7 root 2x over x, and that's done. All right, so we're going to do 13 together, and then I'm going to give you some time to work on 14, 15, and 16. So in 13, some of you guys like to multiply these binomials with the boxes. If you like the boxes, you can go back to those, okay? Some of you use FOIL. I personally just distribute. So I distribute the 1 to everything in the second set of parentheses, and then I'll do the same thing with the root 2. So 1 times 5 gives me 5. And 1 times negative root 2 gives me negative 5 root 2. So I multiply the 1 times everything in the second set. And now I'm going to multiply the root 2. So I'm going to do root 2 times 5 and root 2 times negative root 2. Yes? Can you say that one more time? You're absolutely right. I was looking at something else. All right. So she points out that I am completely wrong. Can I start over? Okay. Thank you for that. All right. Help me out here. 1 times 5 is 5, right? And then 1 times negative root 2 should be negative root 2, right? All right. Then root 2 times 5, that should be a positive 5 root 2. And then root 2 times negative root 2, those are the same root, so I can multiply those to make minus root 4. If you just wrote minus 2, you are not wrong. But I'm just showing the step here. All right. So here I have a minus 1 root 2 and a 5 root 2, so I can combine those two to make 4 root 2. I'm going to bring down the 5. And then square root of 4 equals what number? 2. All right, so my final answer will be 5 minus 2 is 3 plus 4 root 2. Okay, so I'm just going to go over these quickly. In this one, we distributed the root 2. We got root 6 minus root 20. They're not like terms, but I can simplify root 20. I'm going to make a factor tree. 4 times 5, 2 times 2. So I have root 6 minus square root of 2 times 2 times 5. The square root of 2 can come out, so that's going to be 6 minus 2 root 5. And the next one, the common mistake is that people think that they can square each term, but to square a binomial means to multiply the whole binomial by itself. So what we're doing is multiplying 4 minus 2 root 3 times 4 minus 2 root 3. 4 times 4 is 16 minus 8 root 3. Another minus 8 root 3. And then negative times negative is positive. 2 times 2 is 4. And root 3 times root 3 is square root of 9. So those two combine to give you minus 16 root 3. Square root of 9 is 3, and 3 times 4 is 12. And then finally, just combine your 16 and your 12. The last one, they're called conjugates because they look the same except that one is plus and one is minus. That'll be more useful when you go to a further math class. So root 11 times root 11 is square root of 121 minus 5 root 11 plus 5 root 11 and minus 25. These are opposites, so they're going to cancel. Square root of 121 is 11, so I have 11 minus 25, which is negative 14.